think I got separate links for these. So, all right, cool. So, we are doing chapter 3, number 6. We just did chapter 3, number 5B. Again, our underlying theme is problem solving. What do you do when you're lost? Well, you lay out what you know. You have the tools. And then you reread the tools and you reread, and it takes time. It takes time to be powerful. This stuff is. Number 6, Galileo changed our world. Really did. Breaking motion down. Newton took it further. Scientific revolution around 1700. Without this, you don't have cell phones, heating, electricity, magnetism, modern technology in hospitals. Problem solving. Let me write this down. I got to keep track of it because I can't keep it all straight in my head. And my dog might bark. I got puppies, something like that. So, chapter 3, number 6. I'll also remind you that you can, especially in the summer, oftentimes I might have other meetings and things, but in the summer, you can come into the Zoom room and work together with others. And that's really where you learn. Just trying it, and correcting each other. In fact, they say that people don't succeed in STEM unless you get used to doing that. And you start remembering it. All right, the first thing you do is you read it. Galileo changed our world. You get a sense. You don't try to hold on to everything. Then you take everything out you take the puzzle pieces out. And then you see where it goes. Just like life, as I say. A 51-meter ramp. Okay. Immediately I'm going, 51 meter? That's half a football field. I did that on purpose to go a little crazy here. Sometimes the numbers don't really make sense, but I thought this would be kind of fun. All right, cool. Half a football field, more, is inclined up from the horizontal. You put a rolling cart with negligible friction at the bottom of the ramp. People say no friction. It's like negligible friction. You hit it so it starts up the ramp at a speed of 2.0 meters per second. Oh, wait. A meter per second is like 2 miles an hour. So that's like 24 miles an hour. You really hit it pretty good. Choose up the ramp to be the positive direction and show it on your sketch. After 2 seconds, the cart's still traveling up, but at 6.0 meters per second. After 2 more seconds, the cart is at its highest point. After 3 more seconds, the cart is traveling down the ramp at 9.0 meters per second. Sketch and label the process to lay out the puzzle pieces. And then without calculating them, there's like 5 parts. This is evil. This is advanced. So when you get to the other stuff, it's going to seem so easy. All right, here we go. Start drawing. 51-meter ramp. When you get to forces and things like that, you'll talk about the angles and we put in some trigonometry, but you're still doing this.
Okay, yeah.
Here's my horizontal sort of. Don't draw 45 unless you mean to draw 45. It's good to see small angles, big angles. 51-meter ramp. So I'm going to make a little thing from here to here. I may or may not need that because not all information is needed. Why did we give it to you? So you don't just plug numbers in. 51 meters. Let's get to make a little symbol up here. From there to there. And I didn't do 51.0, so that's interesting. All right, so I got that. I took that sentence. You put a rolling cart with negligible friction at the bottom, somewhere here, and there's that corner, so that's a funny business. So we have to not worry about too many details, but enough. I'm gonna start at green. I might do states in color, I don't know. You hit it, the cart here, you hit it, so it starts up the ramp at a certain speed. I was gonna make it a circle. State 1. While it's sitting there, who cares, but you hit it. That process of hitting can be analyzed and will when you do forces and stuff. It'll be broken down, you'll see. But you see it in chapter 8. So it starts at 12.0 meters per second. So I'm going to put a little arrow, and I'm going to make it, because I know that that was the fastest of all the time. Go like this. I'm going to say V1. I'm going to make a little list somewhere. I don't know. V1 equals 12.0 meters per second. This is the fastest way to get it done. Choose up the ramp to be positive direction. Okay, cool. This is the ramp. I'm going to just put my little, like this, and make a plus. I'm going to call it plus X, whatever, plus or plus X direction. Show it on your sketch. I did. After 2.0 seconds, the cart is still traveling up, but at 6.0 meters per second. I don't know how far, but I know it's going to do some other stuff. So I'm going to, that's 2 seconds, and then 3 seconds. Wait, 2, I don't know. Still the cart, so I'm still going to draw it the same shape. You could draw separate pictures. If it gets too cluttered, you will want to. Okay. Remember, time, change in time. Position, change in position. Velocity, acceleration. That's all you're looking for. So I'm going to go. I'm going to start my stopwatch here. T1 is 0. I don't know. Maybe I'll do it over here. T1 is 0. T2 is 2.00 seconds. But at 6.0, still going up at 6.0, so I'm going to draw it a little shorter. V2 is 6.0 meters per second. I'm not solving, but I really am. I'm laying the puzzle pieces. This is the hard part. After 2 more seconds, so that means delta T, 2 more seconds. So I could, oops. The cart is at its highest point. Now I know it's going slower. It won't go as far. You don't have to know this, but it's going to go fastest here. I'm going to go here. I'm going to go 2. Shorter arrow, V2, meaning slower. Then it gets to the top. Now I don't know it. I don't know that that's where it is. It gets up to the top. I don't know where exactly that is. So don't make that assumption unless it's clear in the worlds. And usually you have to reword it. The highest point. It's going slower. So in another 2 seconds, it won't go as far. That's physics. That took another 2 seconds. So I'm going to do 2 4.0 seconds, or I could have said delta t from 2 to 3 is 2 seconds. What's V3? Someone tell me. What's velocity 3 when it gets to the highest point at that moment? Stops, right? But it doesn't, it's one thing to stop and sit there like you do at a stoplight or stop sign. And it's another thing to stop and keep changing. So it's still accelerating because it slows down, stops, increases speed, decreases speed, stop, increases speed. It's still changing. But I do know that that is implied in the wording of the highest point. I might put that up here too, just because I want to be able to see everything. Okay, cool. After 3 more seconds, the cart is traveling down the ramp at 9.0. Running out of colors, but I think I got this. I think I got this. Well, that took 2. I'm going to go here, 4. And we don't always know how to draw it, right? At less than that, more than that, I don't know, something like that. V4. V4 is, I'm going to make a mistake. I'll warn you in advance. After 3 more seconds, T4 is 7.00 seconds. Now, it said after 3.00, so I can write that. I just said after 3 seconds. Text can be very sloppy. Sometimes people teaching it can be too. So it might not be that you're confused, it's something is worded wrong. And how fast is it going? There's a mistake in there. Where is the mistake? Our sketches should include key states, instants, times. They should show our coordinate choice and well-labeled variables that are going to go into our algebra so that we know what our algebra means. What's wrong? This is velocity. Is it positive or negative here? Oh, I see it. I checked the chat. Yeah, it's positive, Kawhi, because I got it. That's why your eyes are going all over. It's crazy, but you keep it straight. You'll get it. You can't do it in your head. You can never do this stuff in your head unless it's like something really easy. Positive, positive, 0, negative. And the problem won't work out. You go, I'm lost. I don't get physics. No, you do. You just dropped a little key piece of information. That's okay. That happens. That's why we keep track of it when we go back through it and go, oh, join the crowd. You made a mistake. Compared to the displacement from 1 to 2 to the displacement from 2 to 3. 1 to 2, 1 to 2, 2 to 3. So I'll just, when you think about that, and I already did it because I think about those things, but again, with practice, when you're new, you make more mistakes. I know that on average, I'm going faster. Now the average, by the way, the average is not always this plus this divided by 2. Average velocity is displacement over distance. If the acceleration is constant, which it is in this case, then you can do this plus this divided by 2. That's a second. Get to that later. But it's going faster in those 2 seconds on average than it is in these 2. So it's going to go farther, and that's why I drew it this way and then not as far. And then 3 seconds. So I don't know exactly where it is. I'm just going to go past that. What information is implied? That's implied in the wording. What's the average acceleration from 1 to 2, 2 to 3, 3 to 4, 1 to 4? Be careful with the plus minus. Again, it's like, oh, my brain hurts. That's why you don't want to try to do marathon sessions. Come back to it. Brains work much better. People that speak lots of languages know this. A, have, earlier to later. Any earlier to later, 1 to 2, 1 to 3, 1 to 4, whatever, is defined as the change in velocity earlier to later, where the plus and minus matters, over the change in time earlier to later. I want to write that out. That's velocity later, which could be plus or minus velocity earlier, which could be plus or minus. When that's minus, I recommend putting minus over, and I'm just going to put delta t earlier to later. We could do that. Well, I have everything. I know the time for me between each of these. I know the velocities, but again, when the later is v4, I've got to put in a -9 here. And you have to be careful. In all of these, the v earlier would be positive. Units, well, it's going to be meters per second. Per second. That's not how fast you're going, it's how abruptly or gently you're increasing or decreasing speed. What can you tell me about the acceleration from 1 to 2 and from 2 to 3 and from 1 to 3? What can you tell me about the acceleration? Not a number, something else. Which way is the acceleration? What direction? From 1 to 2, you're decreasing speed. So the acceleration is opposite the velocity. In this situation, and you can't just memorize it, don't oversimplify, that direction is negative. It's true from 1 to 3 as well. You're decreasing your speed. The acceleration is opposite, which is negative. From 2 to 3 as well. Decreasing speed, acceleration is negative because you chose that. It's this way, whether no matter what. From 0 to 3 to, so I'm sorry, from 3 to 4, you're increasing speed, which means with the velocity, but it's that way, so it's also down. Negative. In fact, you'll find between any of these two states that the acceleration is negative in this case, while you're decreasing speed and while you're increasing speed. And we can't keep that straight in our heads. You can't build a bridge like that, or we had that horrible collapse of the condo, right? You can't engineer like that. You can't do surgery like that. You've got to keep the details straight and have a method for checking. And this will get it right. Any questions so far? What information was a red herring? That means information that's there to confuse you or distract you or throw it out. Well, for this, I didn't need to know that. Can an object be increasing speed if the acceleration is negative? I hope you know now that absolutely. If you're increasing speed, the acceleration is in the same direction as your speed. If that's negative, then that's fine. If you're decreasing speed, the acceleration is opposite velocity. Decreasing speed, that might be positive, but they're opposite. All right, another good problem that we're really breaking it down. You see all the little bits in here that no wonder we lose so many people in STEM. You guys. Questions? Good for the day? Yeah, I'm glad you guys are coming in. Keep at it. Keep struggling. We call it the positive struggle or the good grind. And it is amazing when you get something that you thought you couldn't do, and all of a sudden it's easy. Go, why was it so hard? Because it is hard, but you got good at it. It's quite, it's quite profound. Changed the world, this stuff. Although they didn't have as good a notation. So, yay. Tomorrow we got 2 different sessions to try to accommodate different people, people's schedules, and keep trying to solve these puzzles as much as you can by the same way of read it, lay it out. Then you always get it. Otherwise, it seems like magic. Oh, you just know how to do that, or you memorize it. Okay, cool. Should we call it a day?